Hello, and welcome to my online whiteboard video for PIDP 3240. My name is Nick Charette. Today we are going to look at how to determine building heat loss calculations, which will enable us to make efficient and economical decisions when designing a heating system for your home. In order to get started, we need to identify 4 factors that will have a great influence on design. Number 1 is the design temperature difference. This starts off with the desired temperature inside the building. It's called indoor design temperature and is on average 72 degrees Fahrenheit or 21 Celsius, but can change depending on the type of occupancy or personal preference. This is subtracted from outdoor design temperature. These temperatures are the average coldest temperature experienced for each region throughout the province as published by the National Research Council of Canada. For example, if we had a building in Prince George at an average January temperature of minus 28 Fahrenheit, we would experience a difference of 100 degrees Fahrenheit. But in Victoria, we would only see a 49 degree Fahrenheit differential, 2 different loads based on location. The second factor to consider is what the exterior of the building is made of and how the heat will conduct through those materials. This is called transmission heat losses. The third factor would be the infiltration or exfiltration, which is the movement of air via convection current, pressure differential, and wind loads throughout openings. And the last factor to consider is slab edge heat losses, which is when floor is in contact with ground and losses occur primarily via conduction, and this is a separate calculation based on linear length of exterior slab edge. In order to design a system, we will need surface area, volume, and type of construction, which can all be determined from the building's blueprints. First thing to look at is the outside wall construction. What we are concerned with is the material's ability to resist the transmission of heat. Maybe at the hardware store you may recognize the use of R values, but for our calculations we will use the reciprocal, which is called a U value, which is the complete resistance of the wall, and this will be different for each assembly when it changes construction. So if R values are given, 1 divided by the R value equals the U value. We must also separately consider values for outside windows, doors, ceilings, and floors, because they will conduct heat at different rates than walls. The last thing to consider is room volume, which will affect infiltration rates, and this is based on construction and layout. So scenarios like how many windows or the presence of a fireplace will affect the movement of air. For most of our calculations, we will use tables to keep organized and work from room to room. Right now, we will use the example of this kitchen. So windows equals 25.5 square feet at a factor of 0.59, which equals 15.045 BTUs per hour per degree Fahrenheit. Net walls, which is walls minus windows and doors, times a factor, equals 15.288 BTUs per hour per degree Fahrenheit. If we don't have anything above, it's a cold ceiling, which will lose heat. Surface area, 884.6 times its factor, means we're going to lose about 5.5 BTUs per degree Fahrenheit. Because we're on a crawl space, we'll lose heat through the floor. 184.6 square feet times 0.036 is 66.456. We have to take the volume of that, which will give us an infiltration of the room, times its own factor, means that we're going to lose 17.76. All of those add up to 120 BTUs per hour per degree Fahrenheit. Now we must multiply that by the design temperature difference. So for Prince George, which was 100, that would give us a total loss in the room of 12,005 BTUs per hour. We'll do this for each room throughout the house, and those will all add up to a total loss throughout the building. Once losses for construction have been determined, we must consider any loads in addition to heating for comfort, like indirect hot water tanks, swimming pools, or outdoor radiant panels used for melting snow on drives and walkways. Once all loads are considered, we can select a source and design emitters based on individual room losses. Thanks for taking the time to watch this. I hope you enjoyed. Cheers.